Hi, Josh.
Hey Diana, how you doing
Hi.
today?
Good, good. I'm excited. We never get a chance to do this stuff
I know, I
together.
feel like we're always running around and we talk about this stuff, but sit down and can actually record it's going to be fun.
And what better topic?
I feel like it's such a cool time to be doing. I've been doing this now for, working in this company for 10 years and implementing these systems across, probably 100 different projects and getting to see the evolution of technology, but like particularly around the emergence of Lakehouse, it's kind of a culmination of a bunch of really good architectures and tools converging, and it's kind of the best time to be thinking about this type of stuff. So I'm very excited to share some of that.
Absolutely. So let's get started.
Great.
Yeah, so I figured I'll just start with the basics. Can you tell me, maybe give me a definition of the lake house architecture?
Sure. Yeah, I think this is you can see this buzzword flying around quite a bit. So to get to the definition of a lake house, I think there's a couple other definitions that are required. So we first should just start off with kind of where we've been and this kind of common technology with a data warehouse. I think that's one thing that we'll start to see what the data lake house architecture is in context of data lakes and data warehousing. But a data warehouse is a structured data environment that's really designed for specific consumptive purposes. So you get a relational tool, you power it and design the system in a way that makes it very easy to read and consume data from. And that can power analytics and BI and reporting all downstream. And that is a necessary layer for serving out data, but it's limited in what it's capable of. On the other side of the equation, and moving into why the data lake architecture emerged, is we have more data that exists other than just structured data. We have video and audio and denormalized data sets of all types, and data lakes are fantastic for that. They're really good at storing raw data and large sets in the cheapest format possible. And you can kind of just dump into anything with this data lake. And that really was fueled by the need of data science and machine learning, which needs much larger sets of data to have areas that you're not trying to normalize and structure all your data like you are for a warehouse and structure reporting. But it brought with it that open architecture and just raw storage brought with it a lot of problems. And so, I think we're coming up now, warehousing and even data marting, the structured data environment have been around, since we've been doing data structure. Data lakes emerged kind of in the 2010, 2011 area, and that became, all the way to store this massively growing unstructured data, but we lost some things in the process. And Data Lakehouse is the emergent technology that was really led and spearheaded by Databricks to address a lot of those problems. And it's, I think, really introducing this concept of a metadata layer on top of a lakehouse to fuel all architecture. And so you're trying to enable all of the different use cases you have, whether it be machine learning, analytics, kind of raw data analysis, ownership and centralization of data. And the warehousing that's required, but putting a governance and a metadata management process in play that enables a lot of what structured data comes to play. So it's really an evolution of architecture, and I think enabling a lot of the function that we're getting out. And it's worth diving in a little bit of kind of what those features are that we've arrived on.
Excellent. Well, can you tell me why do you think it's gaining popularity right now in the data management landscape?
It's a great question. And I think you have to start with like, what are the core questions that we keep emerging on when we're dealing with data? And then that will answer why this solution is so effective. So you think about as we put data together and this is an overtrodden use, but you're always trying to get the business value out of data or get the value out of your data. That's always the goal. Data for data's sake, not really interesting. Data for analytics, data for ML, data for BI, reporting, all that. That's the interesting stuff. The thing that I find when you're kind of answering those questions, um, what what data do we have is a really hard question when you get both huge volumes and large access problems. Then you also start thinking about like, is it trustworthy? How do you access it, or who you allow to access it? How do you keep it secure and compliant? I think these are all questions that, as you scale your complexity, you actually start needing to scale the tooling around helping make that accessible and make it manageable. And so that's really what you think about the gaining popularity is adding a layer, that metadata management on top of a data lake, which we call the lakehouse environment, is really adding a kind of handful of these benefits that we get with the kind of data warehousing, but on top of bringing that metadata layer in allows us to implement it on top of the unstructured and more lakehouse architecture. So specifically, that's a few features. So you get what's called ACID transaction capability. So it's atomicity, consistency, isolation, durability. This is something that's very enforceable on structured data, but very hard to do with unstructured, varied, highly changing environments. But when you bring a metadata layer on top of it, that's something you can enforce in that layer. And that's really crucial when you're trying to keep consistency of things like replayability of data or lineage, these things that you need to, when you have just a dump it into a big bucket or an object storage environment without another abstracted layer, it's really difficult to keep track, to enforce security, to know even what you have for data resources, and to have knowledge that develops around your data as you grow. Other features that are really key to the kind of metadata management implementation are things like schema management and schema enforcement. So having definitions, enforcement, and then seeing evolutions of that definition as you start to do transformations on your data, having a centralized place for managing that is just so crucial. And so again, it's fantastic to dump it in to a single store, and then maybe you have your data lake and it runs out to data warehousing. But what if you have different, slices of your customer data? What if you're constantly updating it? What if you want consistency about transformations and abstraction on your customer data that different departments need? What if you want that computational layer to come back in and be used in machine learning? You actually need an independent abstracted area, and that's what your metadata store coming out of the Lakehouse architecture evolves. So schema enforcement can say, this is the type of data that you want, even when you're isolating down to the raw data that's coming in the data lake. The metadata can associate what type of data that needs to be. So that can be enforced all around, structured, unstructured, image, video, sound files. It's at almost any scale. And then the other thing that comes out of it is just a set of tools that can enforce both traditional batch management and streaming. And that's where a lot of the tools are being built around, is making sure that to get streaming and batch, and ultimately moving to parallel system computing, so for scalability, there's systems designed to think about that through the metadata management side as well. The other thing that's really compelling, and there's actually a huge amount of activity in the space right now, is around the open standards emergent. So the idea of open source or open standards, we have forever, used to be, we'd go out and ask Oracle or IBM or a proprietary system. And when we were interfacing with a computing layer, there was some behind the scene magic that was happening that was proprietary to get and query our data. With the querying engine or whatever we compute against that language, even how the data was structured, that was handled kind of by a closed source environment. Well, we've really evolved that's no longer the case. We are not okay with giving our data rights over, our data structure over to organizations. And so what's emerged are a series of open source tools and open source standards more readily, that all tools, the Databricks are built on open source tools, literally Delta Lake and Delta sharing, and building on the underlying processing layer like Hudi and all these other tools, OCR. Everything that we're dealing with here are technologies enabling consistent structure for interoperability and abstraction between multiple tools. So the concept of data lakehouse is not to say, well, there's a lake you build, but you build in a way that can plug in all the different tools, even from ingestion to storage to API to consumption. Each of the layers are actually designed in a way that's abstracted from the tools themselves and built in open standards. So I think that's if you come back to why the popularity is it's really just around thinking about how do we build in a way that will be, we always use this term, future-proof, scalable, consistent. That's what that new layer is on top of infinite data availability, that, how data lakes turned into data swamps for years. This is exactly what we're pressuring into, is saying, let's take the best of both worlds, a little bit of what structured data is able to enforce, but allowing for scalability and abstraction by building this metadata layer in.
How does Databricks support the implementation of a lakehouse architecture?
Yeah, so the term lakehouse was actually coined by Databricks in about 2000. So, commensurate to what Databricks is open architecture, and they're consistent to driving forward ownership of data environments, they've built kind of the leading architectural pattern, and other tools emerge around it. But Databricks has really been the core implementer of the like a lot of the tools that exist around lakehouse design. Again, I think it's important to answer specifically, making sure it's clear of what lakehouse is and what it is not helps clarify a little bit about where these tools sit. And I think saying that Lakehouse itself is really just it's a vision of an architectural pattern, of like having this abstracted data layer. There's kind of like 5 layers that exist in Lakehouse pattern: the ingestion layer, the storage layer, the metadata layer, API layer, and the consumption layer. Each of those is an architectural pattern, noting that important addition of the metadata layer. So it's not specifically a set of technology. And that's really what Databricks has released out in the world. So they have a leading architecture with great tools like Unity Catalog, for really good metadata management, default, their ability to work with, there's kind of 3 core emerging technologies that are leading a lot of how the metadata management layer is emerging. So these will be familiar. There's the one that is open sourced and created by Databricks is called Delta Lake. It is one amongst another platform called Iceberg and one of Apache Hudi. All 3 of these are kind of the leading emerging file formats that you're using to manage all the metadata layer. And there are pros and cons of each of them. I actually think that it's a really good environment to have each of these existing, but not only is the architectural kind of framework led by the open source effort led by Databricks, it was adopted by many others. You'll see across the industry, this is where most architectural patterns are moving, but they are backing and supporting for a while what was the leading pattern, which is Delta Lake. As of this year, Snowflake and Databricks both have really backed and supported Iceberg, Apache Iceberg, which is another open source tool for underwriting a lot of it. Databricks actually acquired Tabular, which is the original Apache-based design company that built Iceberg, as well as Snowflake releasing Polaris, which is their open source version of Iceberg itself. So we're seeing these patterns becoming normalized, and that's great for industry. We want to see huge amounts of open standards for interoperability between how the metadata is structured. So that means it can communicate to all systems. Instead of it being one proprietary system, the premise of Data Lake is going to allow you to plug into each of these tools. So conceptually, you could build a storage system on multiple clouds, abstract with a similar metadata management system of all of it. You can have some stuff in object storage and in S3, pulling into a Unity Catalog and Databricks, plugging into some of the best of class in Snowflake, downstream with your leading BigQuery engine for some high performance compute, and plugging into Tableau and Power BI and a consumption layer. That would not actually cause as much headache of a complexity of a system design that would have existed before if you're trying to integrate a bunch of different aggregation layers from all these consumption tools into like there would be no place for the standards of data to sit outside of those tools. So getting back to the core of the question, your Databricks pushes a lot of these open tools, helping that interoperability of a framework. But I would say candidly on the other side too, the premise is ownership of data, not being as locked into your vendors, so you're actually able to not only choose the best tool for the job, but also know that when the tools evolve or things change, that you're equipped for that transition as it comes in play. And that's really the philosophy that Databricks has been pushing. And they have some of the best in class tools, but they also integrate with everything else. And that's kind of why we like to design systems that take the best of kind of all worlds at this point.
What are some best practices for data ingestion, storage, and processing in a lakehouse environment?
Yeah, so there's some things to be considerate of. There's like, as you build abstractions, and that's somewhat of another term for complexity. I won't, there's a nature of that if you put ACID or schema enforcement in, that means you have to put your data in a certain way, right? That schema enforcement means you can't allow data to come in unless it's in that type. So there's transformation that needs to occur, and as opposed to just dumping in the data lake as the ways of the past, there's more work to be done. So I think there's a couple of things that you really want to be considerate of before you really just embark on this journey. First off, having a good understanding of some of these kind of core enforcement patterns that you're looking for. You are getting benefit from constraint, right? The idea of putting something, having ACID database and transaction layer, you get a lot of benefits from that, but you have to make sure you understand how to, make sure that where those transformations live to get your data in a position that is ready to be consumed in it. That's a lot of the benefits you get when you choose a platform. This is where Databricks has a bunch of kind of native configurations built in to enable the metadata abstraction when they're storing your data. If you look at like their tools like LiveTable or their managed tools internally, they allow for this to be built, the metadata abstraction to be as part of the process. And so you want to kind of decide about how managed you want this infrastructure. If you want complete interoperability, there's a little bit more of a learning curve to understand how to enforce these tools and make, you have, for example, Apache Hudi, you can natively build a lakehouse on that technology across many platforms. You can do it natively in Azure or AWS. But there's a lot more configuration that comes with that. So that's that making that decision about how much you want a platform to manage this versus the tools themselves. And I think that's the depending on your internal expertise, you can get a lot of these benefits, but then you want to allow the Databricks of the world to help auto extract and leverage more of live tables, and being considerate of the costs there. One of the big benefits of extracting the metadata that you can do is you can do a bunch of work on, like a lot of the problems with data lakes is you'd see a lot of over partitioning occurring when you're doing tables. This is a classic thing from a data ops environment is you're coming in and saying, all right, we want to shard out or partition a lot of data, so you can get these small data tables that are maybe not optimally designed and get really expensive querying time. Well, the metadata management allows you actually to make decisions, use your data without necessarily having to shard or partition your data as much, because you're going to be representing it in a way that's for the query or even the consumption need that you have. But in that example, you'd want to be careful making sure that you are able to extract the data in a way to make those deductions. And so, or you're putting your data in an environment so you can get that insight. Those are the types of examples where instead of focusing on partitioning, you're focusing on your metadata management, and then you get the byproducts of better compute downstream with the usage of how you can break out your data consumption on that layer. So that's a type of example of stuff you get. There's other ones that would pop up immediately. When your metadata data can contain a lot of information like orchestration jobs, transformation modeling, field profiling, recent usage, changing lineage, of course, and past data quality incidents. All that stuff's available in your metadata layer. And if you're going to try to implement a system, you need to, independent of a managed platform, that's something that you want to make sure you're getting all of the type of metadata extraction that you need. So I think the biggest piece is knowing what you're looking for in your metadata management as you think about this, or selecting a platform that can help kind of automate some of that extraction as well.
What are some of the common challenges organizations face when implementing a lakehouse architecture, and how can they be overcome?
So as I mentioned, one of the biggest benefits of this is it's not a tool set or a platform, it's a architectural pattern, right? So inside of that, you have choices. So one of the things that you'll note is it's not a fully complete, like Lakehouse as a set, it's not a fully complete system. I even just as making an example here about formatting for your metadata management, you can have like 3 choices that you're going on there. If you pick Databricks, they're going to use Delta Lake. That's the platform they drive in. If you're using other tools, you'll have choices between the other technologies that you're getting in there. And so this is a perfect example of pitfalls being, what are the pros and cons between that? There's a barrier to entry to understanding that. And then you're making a decision when say you do a proof of concept inside your organization, then you're working on inherently a smaller subset of data. What happens when you scale it up? What if you need to be able to move from batch to streaming? Did you architect your metadata extractor and your metadata formats to be ready for that when you're from small to large? It's classic questions that you have to answer. And inherently, there's just a barrier to entry in some of these understanding the future proof. We work with clients all the time to help them answer these questions, where to think around the corner a bit as they're starting to architect systems. So I think the inherency, its flexibility, and its abstracted nature means you have more optionality. But that's also a challenge. Another one, the second area I would say is a big piece where clients, often really lean on us to help see this across a lot of areas, is really considering about designing to make sure you're supporting it. You have different standards, like there's been a lot of your frameworks and standards and patterns, enforcement that you have to consider. It takes a little bit of opinionation on where stuff sits, and not just a single ETL job that dumps into a data lake. It actually has to sit across, different patterns from your raw data to your business level aggregated data. That classic medallion architecture of raw to filtered and clean to business level. There's more pieces emergent inside of that, the newer kind of input layer. So I think that's another piece that's really crucial for people to be considerate of, is picking the right technology, picking the right system design. And then the third thing I would say as a pitfall is it's still evolving, right? As I think we're talking about, though it is a pattern, there are tools that are emerging that are, rushing towards feature parity, that are competing with different pieces. Even just as we're talking about interoperability of kind of these core three technologies that we're dealing with, Hudi, delta sharing, and Iceberg, there are some that write one way and don't read from the other just because they're emerging tools and they have different features. And so say if you're trying to plug in with a system that natively uses Hudi and you're trying to make it compatible with Iceberg, different platforms support different technologies in there. So you have to be sensitive that the premise is total interoperability, but you also need to then look under a hood and say, oh, well, this is where we think we're going, or here's benefits we see of different platforms and what do they support? There's some that just will do read, or there's recent technology inside of Databricks, for example. They just released a tool called Uniform, which allows delta sharing to generate interoperability to Hudi and Iceberg, which is great, but it's one directional, meaning if you're using a platform that generates Iceberg there are ways to make that work, but you have to consider that interoperability in reverse. This will keep evolving. We literally just 2-3 weeks ago heard Tabular, which is the foundational Iceberg company, was acquired. So we know that's going to become a stickier integration layer. It will go bi-directional. However, it's not quite there yet. And there are other tools like OneLake out there that help with open source bi-directional file formatting tools, which may be needed if you're doing huge volume, multi-file format metadata management. So I'm getting a little in the weeds here, but that's an example of a type of thing. It's just making sure we're looking around the corner for what are the platforms that are leveraged, what's the expectancy of scale, and just thinking about a couple of the system designs to get over that. The openness of the system is both a benefit and a challenge.
Yeah, wonderful. Wow, that was quick. You covered a lot of ground in a short amount of time. I have one more question for you.
Great.
Can you share a case study or example of a successful Lakehouse implementation?
Yeah, I think that most exciting examples and use cases, model how we think about data architecture in general. So one of the approaches that we take as a firm, and generally what is acceptable in the market, is considering iterative design. So you want to build a use case that kind of sees a system end to end. So we recently were working with a private equity firm that was looking to unify data across multiple portfolio companies, investments that they've made, so they could extract a more holistic vision of the progress and the evolution of the KPIs of these companies. So that's an interesting application. First off, they wanted to build a unified data environment, stand up a BI tool on top of it, but we needed to go leverage technology that was able to capture not just the immediacy of building a dashboard to get the analytics, but inherently they wanted to plug in their internal analysts to be able to do additional, not like kind of self-service analytics on top of that. So immediately the request is something interesting. It's a unified data environment because they want to fetch it from a bunch of different sources. It's a report, and it's a let's set ourselves up for the best environment so we can answer questions that we don't yet know we have. So that is a very common approach that we've had. And they didn't really have much of a centralized data store. They had, all the companies had downstream data systems, multiple different cloud environments. But the portfolio company, the private equity firm wanted to bring those together in one lens. They had to plug into different systems. Perfect candidate for what we would consider as a lakehouse architecture. So leveraging Databricks, we stood up a Delta Lake connected to multiple systems. So we're able to fetch systems from raw S3, from existing warehousing, all the way down to even like CRMs, that's kind of on the ingestion layer. With all of that, though, there's a huge amount of many different entities. So we had this concept of different portfolio companies. That's not something natively that exists by each data system. So we're able to architect that in the metadata store. And so now we can do querying of like, let's apply, what does that model layer look in the metadata store that exists? Well, think about immediately once that's designed, we can start adding enriching that metadata layer to categorize by different sectors or by different performance metrics. Now think about how powerful that analyst, when they come in and they're just trying to get the raw data, forget a BI tool, they now have all this layer of analytics filtering that's applied that they can answer questions so much quicker. And of course, with tooling that exists now, their LLMs sit right on that data layer inside of Databricks. There's really exciting tools like AI BI that Databricks just released. It has all that semantic context, leveraging the metadata layer, and they're able to query as an analyst piece right inside of it. But the other thing, the goal of the private equity firm is ultimately to get a report that they can communicate back to their executives and their limited partners, their investors. And so as they evolve their KPIs, like how do they think about EBITDA? Is it quarterly reflecting or shifting it from different businesses that run on different financial schedules? That can be introduced into the metadata layer and made transformations so that we can actually see which ones need that. All that lineage and the visibility of transformation is visible to the analyst. So when they're talking about EBITDA, it's consistent across all their companies. And so the analyst can work in the raw data layer, get questions really powerfully fueled by LLMs. We have a reporting that we know has integrity and consistency of what EBITDA means across a bunch of different companies that technically define it separately. And that metadata catalog keeps track of all of it. So right there, a really basic use case of a single kind of executive report and one analyst going in and trying to understand it, one instantiation of this system from a pretty complex, varied environment, already stored all the logic in the Lakehouse architecture to empower this user in just 2 business cases. So in the course of a couple months, we have lots of data aggregation, super powerful analyst, and a really trusted high integrity report that they could use for financial analytics and reporting up to their investors. Amazing amount of progress to get to some of these really kernel facts that we talk about is, do we trust our data? Where does it sit and what do we have? Answered right out the gate with something like a Lakehouse architecture.
That's awesome. Yeah, that sounds like a lot of fun, actually, putting all that
very
together and
powerful.
offering all that value to the private equity company. Well,
Yep.
this was great. Sitting with you and having being able to ask you these questions. I want to do this again. I
Let's
have
do it
more
again soon. There's
questions
so much
and
more.
another
Yeah.
topic. Yeah.
Thanks, Diana. Fun
All
to
right.
fun to dive in on this with you. Thanks.
Yeah. Thanks so much.